Thanks for stopping by for another Technician's Toolbox video. In this video we will cover the GM TAC system. Please be sure to view the other videos in our electronic throttle control series. On the Type 1 system, the TAC module receives the AP1 and 2 and TP1 and 2 inputs and is control of the throttle plate motor. The TAC module plays a limited role in system diagnostics, and the brain behind the operation is the PCM. APP data from the TAC module is sent to the PCM via the UART data lines. PCM sends a throttle position command to the TAC module. The TAC module controls throttle blade position by applying power and ground of the throttle blade motor. Directional changes are made by switching the polarity of the circuit. The TAC module is also receiving throttle blade position information from the TPS sensors and sends it to the PCM via the UART data lines. Type 2 system operates in the same manner as Type 1, except that the TAC module is incorporated into the accelerator pedal assembly. Type 3 system, the TAC module is incorporated into the throttle body. Type 4 system has the TAC module functions assumed by the PCM. This requires a new PCM with the ability to integrate the TAC functions. Driver demand input is provided by the APP sensor. This input must be redundant and is error checking. PCM contains the operation and fault setting strategies. It determines desired throttle blade position and other functions and sets DTCs and illuminates the mill upon failures. It is also responsible for entering limited power mode if a failure is detected. All system types use an electrically controlled throttle blade. A DC motor moves the throttle blade from default spring-loaded position. Directional changes are controlled by switching polarity of driver circuits contained in either the TAC module or the PCM. TP sensor is used for throttle blade position feedback. It determines the actual throttle blade position and is redundant and error checking. The APP sensor is mounted on the accelerator pedal assembly. The APP is actually two, or in early systems, three individual APP sensors within a single housing. There are separate signal, low reference, and 5-volt reference circuits. APP sensor 1 voltage increases as the accelerator pedal is depressed. APP sensor 2 voltage decreases as the accelerator pedal is depressed. Sensor 3 voltage decreases as the accelerator pedal is depressed, but at a different voltage than sensor number 2. The throttle position sensor works differently than on a mechanical controlled throttle. TP sensor is two individual sensors within the throttle body assembly. Two separate signal, low reference, and 5-volt reference circuits are used to connect the TP sensor and the PCM. On the earlier systems, TP sensor 2 signal voltage increases as the throttle opens. TP sensor 1 signal voltage decreases as the throttle opens. An illuminated mill is often the first sign of a problem with the TAC system. However, stalling, AC shutoff, and engine surging may also occur. The geometry of the throttle body will not tolerate changes in airflow due to carbon buildup. A quick tip: a slightly binding throttle blade, a flaw in motor circuits, etc. will cause the system to flag an error, set a DTC, and put the vehicle in limp mode. Things that can go wrong with the system: software problems, initialization problems, communications problems, AP sensor problems, TP sensor problems, TP motor problems, TAC module problems, PCM problems. For more detailed GM TAC diagnostic tips, please contact your parts supplier for information on the PTS Electronic Throttle Control One-Night Clinic. The vast majority of TAC wiring issues are with full-size trucks. As can be seen in this scan data, the update rate is slow and is interrupted by higher priority functions. The APP and TP PIDs originate in the TAC module and are transmitted over the UART circuit to the PCM. TAC commands will override the transfer of data PIDs. The TP and APP agree-disagree PIDs will change the instant a glitch is encountered by the PCM. Monitor these PIDs and wiggle the harness and connectors. This tip can save a technician time and aggravation on trucks. If you find broken wires near the throttle body connector, you may be tempted to order a repair harness connector and just replace the connector. After the connector replacement, the problem will still be present. Save yourself time and aggravation by replacing the complete harness from the throttle body to the TAC module by manufacturing one. Throttle body connector is available, but the TAC module connector is not, so you'll have to reuse the original one from the vehicle. The integrated TAC system contains the TAC module, TP motor, and TP sensor in one unit which communicates with the PCM. The accelerator pedal contains two individual accelerator pedal position sensors within the assembly. The APP sensors 1 and 2 are 3-wire potentiometer type sensors. The PCM provides the APP sensor with a 5-volt reference circuit and a low reference circuit. Both APP sensor signal voltages are low at rest position and increase as the pedal is applied. Note that APP1 produces a steady voltage signal, while the VREF for APP2 is pulled to ground by the TAC module at a fixed frequency. There are 2 individual TP sensors within the throttle body assembly that are used to determine the throttle plate angle. TP sensors provide the PCM with a signal voltage proportional to throttle plate movement. Both TP sensor signal voltages are low at closed throttle and increase as the throttle opens. A word of caution: there is no way to connect test equipment to the TP sensors. The wiring is inside the module. The only way to monitor these sensors is through enhanced scan data. The TAC module provides diagnostic information to the PCM through primary and secondary UART signal data lines. When replacing a throttle body on a GM, clear the long-term memory and turn the key on for at least 1 minute. Then start the engine and perform a basic idle relearn following the service procedures found in the shop manual. We thank you for watching this edition of Technician's Toolbox and look forward to seeing you in the future.